right, this question 33 reads, in the circuit below, a voltmeter of resistance R sub V and an ammeter of resistance R sub A are used to measure the resistance R of the fixed resistor. Which condition is necessary for an accurate value to be obtained for R? So this is a potential divider circuit. We've got a potential difference between this positive and this negative. There is a variable resistor right here, and so we can adjust sort of how much resistance there is at this sliding connector. And then there's an ammeter that's in series right here. There's a voltmeter in parallel to this resistor. We see these nodes here going back to negative. One of the learning objectives is that ammeters are wired in series and should therefore have very low resistance. So here's an ammeter in series and it should have low resistance. We do not want it to resist the flow of charge because when you have currents going through resistors, you have voltage drops. And if we think about Kirchhoff's second law, the sum of the EMFs is equal to the sum of the potential differences. So we put energy per charge into a circuit, we convert other forms of energy into electrical energy at the EMF, right? That's the energy per charge we put into the circuit in order to convert that electrical energy into other forms, right? So the circuit, you know, the external resistor is sort of why we built the circuit, to convert the electrical energy that we put into the circuit from the EMF into other forms, okay? So we don't want to be dropping volts across our ammeter, where the ammeter is just designed to measure what the current is in the circuit. So we design the ammeter with incredibly low resistance. Ideally, it would be 0 so that no volts drop across the ammeter, okay? So the ideal ammeter has really, really low resistance, basically 0. But be careful that you don't sort of focus too much on that right away and then look at choice D and say, well, R is much greater than this if this is 0. Does that have to be true? Is that necessary to get an accurate value? What if we just happen to have a resistor here that's pretty low? Okay, then it won't necessarily be true that R is much greater than this. You know, if this is 0, ideally, and this is a 1 ohm resistor, well, is that really much greater? But could we still get an accurate reading of a, you know, of what the resistance of this is, even if it's low? In other words, is it impossible to measure low resistances? And so take care not to be, you know, too quick to you know, go to choice D by only considering the ammeter and the idea that ideally its resistance is going to be low. Let's consider this voltmeter now, and what are the learning objectives related to that? A voltmeter should be placed in parallel. And so that's right, it is. It's parallel to this resistor, and therefore should have high resistance. We want the resistance of this voltmeter to be very high, so that way it doesn't draw charge, right? We don't want the charge to be flowing through our voltmeter. We want to be measuring the potential difference across the resistor that we're sort of wired in parallel to. And so ideally, the voltmeter is going to have infinite resistance. The ideal ammeter has 0 resistance. The ideal voltmeter has infinite resistance. And so it doesn't draw any charge going through the branch that it's connected to. If we think now that this voltmeter would ideally have a resistance that's infinite, then it's certainly going to be true that R is much smaller than R sub V, because any value for this resistor that you plug in, even if it's like 100,000 ohms, that still is much smaller than infinity, right? Any value is much smaller than infinity. And so A is sort of a necessary condition that's always going to be true, where, you know, again, D kind of seems reasonable upon first glance, but if you think through it a bit more carefully, you can really say, well, A is the best answer to this. You know, the resistance of this should be much smaller than the resistance of my voltmeter, because ideally my voltmeter is going to have close to infinite resistance if I want an accurate value. And so choice A is the correct answer to this question.